I'm sure many of you have heard of Phistomefel Ring, and in this video, we will not only show that it's true, we will show that there are such rings for almost any size sudoku. For those of you who don't know, Phistomefel Ring refers to the fact that, for a 9x9 sudoku, the digits in the 2x2 boxes in the corners are exactly the same as the digits in the ring surrounding the central 3x3 box. For this sudoku here, we can count up the digits in the cyan regions and compare them to the digits in the blue regions, and see that they are in fact the same. However, one successful case is not proof that it works for all cases, so let's prove it now. To start, we'll mark the 2x2 boxes in the corners as cyan, and the Phistomefel ring in the middle as blue. We'll also mark the regions to the left and the right of the ring in green, and we'll mark the box in the middle as purple. For our proof, we'll say that F denotes a full set of digits, in this case the digits 1 through 9. The purple region perfectly covers a 3x3 box, and thus contains exactly one full set of digits, and we denote this by saying P is equal to F. Likewise, the cyan and green regions perfectly cover 4 columns, and thus contain 4 full set of digits, and we denote this by saying C plus G equals 4F. Similarly, the blue, green and purple regions perfectly cover 5 rows, and thus contain 5 full sets of digits, denoted as B plus G plus P equals 5F. By applying simple algebra, we see that B plus G is equal to 5F minus P, which is equal to 5F minus F, which is equal to 4F, which is equal to C plus G. Thus, B plus G is equal to C plus G, and we can cancel the G from each side, showing that B is equal to C, or the blue region contains the same digits as the cyan regions. Now we will show that a Phistomefel ring also exists in a 16x16 sudoku. For a sudoku this size, the cyan region will be the 3x3 boxes in the corners, and the blue region will be a ring that encircles the 4x4 boxes in the middle. And we will prove the claim that the digits in the cyan regions are exactly the same as the digits in the blue region. Our proof for the 16x16 sudoku will be almost exactly the same as our proof for the 9x9 sudoku. Thus we will start by highlighting the center of the ring as the purple region, and the regions either side of the ring as green regions. Here we can see that the purple region perfectly covers 4 boxes, the cyan and green regions perfectly cover 6 columns, and the blue, green and purple regions together perfectly cover 10 rows. Using our notation from earlier, we see that P is equal to 4F, C plus G is equal to 6F, and B plus G plus P is equal to 10F. Again, using some basic algebra, we see that B plus G is equal to 10F minus P, which is equal to 10F minus 4F, which is 6F, which is C plus G. Thus, B plus G equals C plus G. Thus, B equals C, and therefore the blue ring contains exactly the same digits as the cyan boxes. Let's see if we can generalize this. Let's say we have a sudoku where every box is n cells by n cells, and the sudoku as a whole is n boxes by n boxes. Each cyan region will be a square with a side length of n-1 cells. Thus the height of the green regions will be n squared minus 2n plus 2 cells. The purple region will be a square with a side length of n-2 boxes. Thus we see that the total amount of boxes covered by the purple region is n-2 squared. The amount of columns covered by the cyan and green regions is 2 times n-1. And the amount of rows covered by the blue, green and purple areas combined is n squared minus 2n plus 2. Therefore, we see that P is equal to n-2 squared times F, C plus G is equal to 2 times n-1 times F, and B plus G plus P is equal to n squared minus 2n plus 2 all times F. From here, the logic is mostly the same as before. By subtracting the purple region from the combined blue, green and purple regions, we are left with just the blue and green regions. And since n squared minus 2n plus 2f minus n minus 2 squared f is equal to 2n-1f, the blue and green regions are equal to the cyan and green regions. Thus the blue region is equal to the cyan region. But this only applies when the side length of the Sudoku is a square number, like 16 or 25. But what if we have a 6x6 or 12x12 Sudoku? Let's find out. Here we have the grid for a 12x12 Sudoku. Each of the boxes is 4 cells wide and 3 cells high, and the Sudoku as a whole is 3 boxes wide and 4 boxes high. For this one, I'll start by drawing the ring. Each of the corner boxes has 1 cell that isn't on the edge of the Sudoku. The ring is formed by these 4 cells and the cells in between them. And each of the cyan boxes is a rectangle, going from the very corner cell of the Sudoku to the cell diagonally outwards from the corner of the ring. Now we will prove the claim that the digits in the cyan regions are the same as the digits in the blue region. Like before, we will mark the regions to the left and right of the ring in green, and the region in the centre of the ring as purple. Thus we see that the cyan and green regions cover 6 columns, the purple region covers 2 boxes, and the blue, green and purple regions cover 8 rows. So C plus G is equal to 6F, P is equal to 2F, and B plus G plus P is equal to 8F. So using our logic like before, we get that B plus G is equal to 8F minus P, which is 8F minus 2F, which is 6F, which is C plus G. So like before, B plus G equals C plus G, and B equals C. Now to generalize. Let's say that a box is A cells by B cells, and the Sudoku as a whole is B boxes by A boxes. We can see that the purple region is B minus 2 boxes by A minus 2 boxes, and each cyan box is A minus 1 cells by B minus 1 cells. Thus, the amount of boxes covered by the purple region is A minus 2 B minus 2. The amount of columns covered by the cyan and green regions is 2 times A minus 1, and the amount of rows covered by the blue, green and purple regions is AB minus 2 times B minus 1. Now I promise this is the last time we'll do this, but we're going to take the purple region away from the blue, green and purple combined regions, and thus we see that AB minus 2 B minus 1 F minus A minus 2 B minus 2 F is equal to 2 A minus 1 F, which is equal to C plus G. And again, B plus G equals C plus G, therefore B equals C. Therefore the digits in the blue ring are exactly the same as the digits in the cyan boxes. Like the video if you enjoyed it, and subscribe for more irrational maths.